computer. All right. There we go. As you may have noticed, under instructors pages over here, instructors page, sorry, under assignments, I posted a quiz last night, but I didn't get the chance to put an announcement or link to it on Canvas. Okay. Which I will do today, but I literally lost power and hadn't had the chance in the middle of making the edit on Canvas. So, so I did send a brief message on Discord while I was cowering in the hallway with my wife and kid to hold up on taking the quiz. If you were there and were able to see it, you may not have seen it because you may not have been on, which is fine. You may not have seen it just simply because you weren't on Discord. Okay, so when you open up the quiz, let's see, you'll see this, the instructions for it, and you'll see that it has a start button and a pause button. All right. Once you start, it will start a counter, which will count up. If you don't have a DRS accommodation of some kind, then you have 45 minutes to complete it. You can pause it, but it's important that please note that closing the tab will lock your quiz. So don't navigate away from that page. Okay. You close that tab or you lose power, right? It will lock the quiz, and that just makes a bit of a headache for me. Okay. Because then I'd have to open it and all your work gets lost and all that stuff, because when I reset it, once you hit start, you'll be able to see the questions. Make sense to everybody? Next, if you get your quiz, if you get part of the grade wrong, it will say like you got the whole question wrong. That's not correct. It will only tell you which ones. If you use idle and no, they are only one of them is a multiple choice question. 3 of them are they're coding questions. What if you use idle? As long as you don't close it, you'll be fine. Navigating away from it also can be a bit risky, like if you go to a different tab, because if you've got 1.5 million tabs open, what will happen is that it may unload the page if you're away from it for too long. And that's just the way that your browser works to deal with memory, right? Sometimes if you've been away from a page for a while, right, and you have a bunch of tabs open, if you click on it again, it will reload, right? So again, just do this here. It's just so that, and this is just simply so I can actually time the amount of time it takes. Okay. It will not lock you out if you take longer than 45 minutes, by the way. Okay. This timer counts up. It does not count down. The late penalty for the quiz is 1 point every 10 minutes. Excellent question. I will link to it on Canvas today, but I didn't want to link into it until I made an announcement, and then I wasn't able to make an announcement. And then today has just been busy and making sure that, and I spent basically the past, I spent the time before I spent a lot of time looking at generators today, but you go to Brunestone. I haven't mentioned, there's going to be 42 points on the quiz. A couple of people took it and they seem to have done fine. So once you start it, it's only 4 questions. So it's nothing to be really too scared about. And they will range in, and as we do quizzes, they'll range in the amount of points they're worth. This one's worth a bit less than other ones. Okay. I will tell you that one of our, they are coding questions. If you're 9 minutes over, you'll lose 0.9 points. You only see one question at a time, but you can go back and first. You can go back and forth between your questions. And are you going to have to do this over Zoom? You don't have to. That's the beauty of this quiz. It's due 9, 7 at, I put down 11:30. So it's due September 7th at 11:30. Okay. So, and you can take it anytime you want. It's unproctored. You can take it anytime you want. It's open book, open note. Do not use other humans, but any non-human resource you can use. Okay. This will be in module 2. To get to the quiz, you just click on this person from Runestone. You click on this person here, and then assignment, and then click on assignments, and you'll be able to see it with all the other stuff. Okay. Are there any other questions about the quiz? I will also post an announcement that will link to it. Yes, you can code in idle or in any text editor and just copy paste it. It covers variables and assigning variables. So if you've done through chapter 2 and if you've done the lab for this week, for lab 2, you should be good to go. Okay. You will be doing module 3 next week. So this is just simply to check, have you mastered the variables and manipulating variables, which we're going to be doing a lot of practice on today. Okay. Yep, it's on chapter 1 and 2. And again, feel free to use Google, feel free to use your textbook, feel free to use any kind of non-human resource. I highly recommend just setting up a separate window. The auto grader deals with that. Now, the one big difference between using this and using doing like these exercises that we have is that while you can run the code, okay, you won't be able to see the tests that are going to be run to grade it. Okay. That's just the way the exams work. So.
Do we have multiple attempts per question?
I mean, you can run that code as many times as you want. Okay. It's just going to tell you whatever output you tell it to do, like whatever print statements you put in. Does that make sense? It's not going to tell you whether it's right or wrong until you submit it.
Gotcha. Cool. Thank you.
When will Monday go over lab 2? Lab 3? Well, after this, we're going to go to that really weird schedule where basically we start on Tuesdays with the content, and then the Monday will follow it. Your score will be shown after the test, kind of. It will tell you how many you got completely correct. So you might make a minor mistake on one of them, and it will say 75 out of 100. But like here, I made a minor typo on mine. If you see mine, I made a minor typo on mine, and it said 75 out of 100. But it only failed like a test. And so I got a 94. This is 1 and 2. Okay.
Does this have only coding questions, or do we have like multiple choice and questions and stuff?
We have one multiple choice question in there.
And all of the rest of them are coding, right?
Yep. What if you have lab before class? Well, you'll be doing lab 3 on week 4. It's going to be a delay like that. And yes, I'm going to adjust the dates to accommodate for that. It's weird. Just trust me on this one. Okay. Like from now, starting next week, the work week begins on Tuesday. And that means that that means that the Monday lab will have the time to go over their labs. I mean, that's the way I've done it, because at the end, there's going to be a Monday that just hangs out at the end of the semester. Okay. So now with that, if you run into any technical difficulties about this quiz, just let me know. The only thing I'm going to be really stringent on is getting the, yes, the questions are going to be based on exercises from Runestone. The only thing I'm going to be really stringent on is that you get it turned in by the due date. That is the important thing for quizzes, that they have a hard deadline, as opposed to everything else, which is fairly soft. Okay. The quizzes have a hard deadline. I'm very strict about the quiz deadlines. If you're running into technical difficulties or some issue preventing you from completing the quiz, let me know ASAP so we can correct it. Okay. If you're running into issues, fine. I'll help you fix them. But don't just not do the quiz or have an issue and not do the quiz and then wait 5 weeks and then come and tell me, because that would be pretty bad. It's almost as though I've had that experienced. All right. Any other questions about this? I'm going to quit out of these since I don't need it. All right. So let's talk a bit about the storm last night, by the way. If you were damaged during the storm, I hope everybody's fine. I got a lot of people saying they weren't able to do that. If you use Google, and question, if you use Google, do we have to cite? If you use Google and you're copying some code, you have to cite. If you're using Google and you learn a concept, I mean, sure, why not? It's always just, if you're ever copying code, question, you got to cite. If you're learning ideas, that's just knowledge, man. The format for citing code is as follows. I suggest doing it of one or two ways, which is, let's look at this. How to reverse a list in Python. Okay, let's go ahead and I'm going to go to Stack Overflow. And somebody says this, even though it's built in or something, and I'll teach you how to do this, but this is just a simple example, right? I wouldn't question you if you didn't cite this because it's fairly straightforward. But let's say you would want to use this, okay? And you've got this code and you test it and it works, right? What I would do at that point is I'd copy this. Hold on one second. Spam. And I would put this in a comment like this, either above my line in question, or I would put it right behind, or I would put it right after the line in question. Either works, so long as it's in the generation, right thing. That makes sense for everybody?
Do we have to write the L brackets ... -1?
No, that's the code. That's the example code that I'm citing.
Gotcha. And on the quiz, how do we cite it so it doesn't take up points?
Like this. You put it in a comment like this.
Oh, okay. And Runestone will be able to recognize that?
I'll recognize that. That. The citations. So a citation, okay, it can't check you for plagiarism. That's something I do. Mm-hmm. Okay. And what we do here is that, and this is not just for the quiz, this is for all your assignments. If you're citing code, just put where you got it in a comment. It doesn't have to be like MLA format or anything like that. Nothing fancy. You probably got it from a URL. So just give me the URL you got it from. Make sense?
And if we for the lab 3, if we use code from Runestone, do we have to also cite Runestone?
Probably not. I mean, good practice, but not necessary.
Okay.
Okay. All right.
Thanks.
Okay. I mean, don't overthink it. As long as you're doing fine, as long as it's fine, it'll work. So now on to today's lesson, okay? On today's lesson, which involves me pulling up Facebook. This is my, and yes, this does have something to do with today's lesson. So this is my front yard from yesterday. And you can see that it's got quite flooded. I mean, the storm was really bad yesterday. This is my backyard. I normally have a small concrete lined stream in my backyard. And it's normally just in that, I would go swimming in that if I had already had a long and fulfilling life. My life has been fulfilling, but it has not yet been long. So that's normally much further down. And here's some other examples. The composite shot we see there of the water level. Race Vines Expressway right here. This is where I used to live. This is the Wissahickon, and it's got some falls here, and you can see this bridge. And this is a picture my friend took on the way to work. Notice the lack of a waterfall. Yeah, so feel free, by the way, after class to share your pictures on Discord because I would love to see them. So here is my question and how this relates to how I can make this excitement from yesterday relate to today's lecture and today's exercise. How many raindrops fell yesterday? A lot, right? And so my question is, so today's lesson, you gotta be at least 3. Thank you, Mark. And when I see somebody else did at least 5, very good. We could use Python to figure that out, and that's kind of, you've got the idea here. So let me go ahead and link you all to today's exercise, today's project. This is project 3 in Runestone. So if you just go open up Runestone, you'll go, we'll go here, and you can scroll down to the project list, which is 3, how many handshakes. Now I'm going to go ahead and drop the link in chat for everybody, so you can just click on it directly. Okay. No joke though. Seriously, whenever you get severe weather to that, listen to the National Weather Service warnings that you get on your cell phone, because I mean, it is really important. Water that you saw, this looks like just water, but if I fell in that, I would die. You know, that is like the kind of drowning, that water is drowning, and it is moving fast, and it is stronger than you can imagine.
I actually just sent a video, a post from Reddit of
yeah, I saw
the tornado touching down.
Yeah, I saw. So anyway, but back to the so there I just would feel very remiss if I did not mention that basically that humans are great, they're tough, but weather is tougher sometimes. So and again, if you're like running into any difficulties like the storm and the after effects prevent you from working or stuff like that, just let me know and I can give you an extension, because I'm not going to be a jerk. Okay. So basically, we want to look at how to do Python to solve some problems. So we're going to be going and looking at how to solve that kind of raindrop problem. Not necessarily today, but I want to kind of show you that the thought processes into those kind of answering those kind of questions, those are possible to try, and it's a very useful skill. So there's a common computational pattern that they call input, compute, output. So we're going to ask the user to give us some input. We'll compute, we'll basically break it down like a word problem, and then we're going to display the results. So here's an example. Enter the number of years, and I will tell you the number of minutes that is. So let's see, 7 years. Lucky number 7, let's go. 7 years is 3,600. And yes, in a second, when I'll be dealing with passwords in just a second as people work on this first part. 7 years is 3,697,200 minutes. Right? What we did is that we asked for input. We took that input and we just kind of broke it down. Okay, years is this many days. There are 365 days in a year. So multiply by 24 hours, multiply, multiply by 24 or days, hours in a day, multiply by 60 minutes in an hour, and so on and so forth. Okay. And so it calculates that. So, and notice we're just breaking it down and doing conversions. Sometimes it's just hard to figure out how to do those conversions, and that's what we're going to look at about. But I want you to try for a second. All right. Here to enhance this problem a bit. So try this just step by step, changing the problem above so that we get to the number of seconds. That should be very much like lab 2, that if you've had the chance to work on it. Change the number of and then try changing this to go the other direction. If you're given a number of seconds, how many years is that going to be? And then see if you can't change it a bit. So I want you to take a gander at that while I go and deal with any kind of runestone issues that other students are having. Okay, so can part 2 return a float? Yeah, sure, why not? Again, these parts are graded based off of your interaction with it. So basically, I'm seeing, did you try it? Not necessarily were you able to complete it, if that makes sense. That's what your grade is based off of for these in-class exercises. I don't want you to be stressed out here. If you try it, you get 100. Okay, makes sense to everybody? So while that is going on, please direct message me if you need me to reset your password. All right. And if you direct message me already, please do so again so that I can see you in chat now, because I was kind of trying to lecture and do multiple things at the same time. I'm so sorry. Okay. Yeah, you code this in here. Ezra, do you have time tomorrow? I saw your direct message. I'm sorry I didn't respond to it. Do you have time to like talk to me maybe tomorrow? That seems
Yeah,
good.
sure. What time?
Send me an email to meet in the morning. Okay.
Okay. Yep. Sure. I can do morning.
Mhm.
Yeah. Are we gonna be putting groups for this or?
I could not this part. We'll do
Okay.
so in a bit. Okay. For the
All right.
next part.
Yep. Thank you.
I'm just kind of temporarily doing this so that I can so that don't worry about your grade on Canvas. Okay, so I see 2 people who have sent me. Okay. So Ahmed, reset password. Okay. And when I reset your password, I will direct message you back with your new password. Make sense? Martin, I see that you have 2. Just you do the, and since you did it on your TUN, I would continue using the TUN. Would you like me to remove your other one? Okay. Done. Okay. I will show you how to print the seconds in a bit. Once after this is done, after this weekend, you shouldn't have to have your password reset after this. This is just, a lot of this is my fault because I forgot to unintegrate it. So give me a second. Iman, your username is your email with the @temple.edu attached to it. So it's TUK 13, yada, yada, yada. Well, minus the yada, yada, yada. That's not actually part of your password. Or username, I mean. Okay, anyone else? I think I got you all. Right? So Parker, yours is TUJ66 yada 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 at temple.edu as your username. Oh, did I not do that? Oh, here, try this one. Yeah, it will stay at 0% until I run it. So don't worry. Corey, and I see your message. I am going to start showing out. I'm going to do this in just a second. All right, so let's take a look at this part. So to do seconds is not too bad. What I would do to do seconds is that how many seconds are there in a minute? We have the number of minutes there are. So I say seconds is equal to minutes times 60, right? To just continue the pattern, right? Make sense? And then the other answer was, well, now that I've got seconds, how do I display that? Well, I have to modify this code to do that, right? Seconds and seconds. This is one way to print thing, which is to have a number of things that you want to print and then have commas between them. I would like to do 7 years again, and we can see that that certainly looks like our previous answer multiplied by 60. Also, really cool thing here again. Look at this. I can go back and forth between my saved code and my previous code, which is really cool. So if I completely mess it up. Okay, so change the problem above so you go to the other direction. Given a number of seconds, how many years would it be? All right, so I'm going to comment this out. So I'm about to do what's called a multi-line comment. And when commenting something out, you're kind of removing it. Actually, I'm lying. I'm not doing a multi-line comment, but in effect it is. This is effectively a multi-line comment. This basically comments it out. The computer ostensibly ignores this. It doesn't actually, but what you're doing is you're creating a giant string literal that you don't assign to anything. It's how you do a multi-line comment in Python. Okay, so the code doesn't really exist anymore. Mind you, I can just delete this for the most part because it's got it saved in the other one. But so here I've got seconds. Enter the number of seconds. And I'll tell you how many, years? And I'm not going to do the part number 3 because that will give you some, that's going to get you directed towards your, that's left for your homework because your homework's got a problem like that. Okay. But suffice to say, it involves doing modular arithmetic or subtraction. The modular arithmetic is a bit more useful to try though. So seconds is, so we've got a number of seconds. How many seconds make a minute? So minutes, assuming I can spell, is equal to seconds divided by 60. You know what? I'll do floats, so it's no problem. And then there's hours. We have, right, we need to go the other way around, essentially. So there's 60 minutes in an hour. So take the number of minutes you have, divide by 60. That's how many hours you have. Now we've got hours. How many hours are there in a day? Well, I've got the number of hours. I know there's 24 hours in a day. Also, just like, let's just take a collective moment and just think about how absurd our time system is, how little it makes sense. 60 seconds in an hour, 60 a minute, sorry, 60 seconds in a minute, 60 minutes in an hour, and then like 24 hours in a day? Why 24? Why not like another 60? Or better yet, why not like have it like it's a base 10 kind of weird thing where you have like, you know, because when we go down to milliseconds, it starts going by divisible. We start doing SI prefixes. Just time is maddening. Yeah, 24 does sound cool. I'll give you that. I'll give you that. Okay, it's just like we'll learn more about how messed up time is, and not just like in the physical way, but like in the human's timekeeping way. Oh yeah, Emily, no doubt. US freedom units are terrible. Metric is so much superior. Sorry, it always gets a laugh when I refer to US stuff as freedom stuff. Imperial. I can never, I sometimes forget what they're called, so I just call them freedom units because it's funny. All right, so 24 hours a day. So then we know that there's 365 days in a year. So rather than multiplying, we're dividing. It's equal to days divided by, and if you get into the zone, it's very easy to like do something like this. So just be careful. And then we can just print out our answer, which is years, and we can, and let's just make sure. So I'm going to take my output from the previous, save and run, drop it in. Oh, unsupported type for string. Now, why did it happen? This is might be hard to see on your screen, but it's because I have an extra space on it. Also, because I didn't convert it. That's also, actually, that's the real reason. Because I didn't convert it into the appropriate unit. So seconds, because, so, right, it was trying to take a string and say, and do a mathematical operation with a string on one side and another. We are dividing because we're going from seconds, which is a big unit, and we are trying to figure out, or rather it's a small unit, but comes in big quantities. So we're converting it to a big unit that comes in smaller quantities. So we know that there's 60 seconds there. We know there's 60 minutes. Sorry, there's 60 seconds in a minute. So we are dividing seconds by 60 to get the number of minutes. You could do float here, by the way, on line 2, but here I'm just converting it into a string, so that will work. And there we got 7.0 as our answer. So the reason we are dividing is so that we can do the conversion, right? We can convert seconds to minutes by dividing the number of seconds we have by 60, because there's 60 minutes in a second, and we just keep doing that and going from one unit to another. All right. So this used to be kind of one of those BS interview questions. By the way, interviewing for computer science jobs is broken and nobody knows how to fix it. There's literally no way to know if somebody's a perfect fit for a job other than hiring them and training them and trying them out for a period.
Well, that and some companies just don't know what the hell they're doing when they hire. Like the one example of the guy who created his own computer language, and it was only like 3 years old, and they wanted somebody with 7 years of experience.
That's an HR problem.
Yeah.
I'm talking about programmers interviewing programmers for programming positions, you know, not just the screening. Now there are good tests we can have to screen to see if you are actually know how to code. So I hit the share the code. That's fine. It will load up for all of you if you reload the page and hit load history, but you don't need to. But anyway, again, we really don't have a good way of interviewing. But that being said, I have done a number of programming. I've done a couple programming interviews and a good number of mock interviews because I do like the puzzles. So anyway, here's one of those not great questions, but it's actually really good for interviews, but great for thinking about and giving your brain a workout. Okay. So how many trees? How many trees are in the state of Washington? Now you could probably Google that, but I suggest you avoid Googling that. Because now the idea here is that you cannot get an exact count because you haven't really gone out and, counted the number of trees. But the idea here is that we can get a good estimate of how many trees are in the state of Washington. There's a fun post you point out by XKCD. Now, if you aren't familiar with XKCD, it's a very mathy, computer sciencey webcomic. It's hilarious. It has some great comics in there. He publishes a book with this blog based on this blog called What If, where basically he gets these really weird questions and try to figure them out. Like here, if all digital data were stored on punch cards, how big would Google's data warehouse be? So Google, they point out, has more data storage than almost any other organization on Earth. And then there's a couple of agencies here that he points out who might have more. Okay, the NSA, everybody knows about the NSA and CIA, but who are the NRO? They're .gov. Who in the world are the NRO? Does anyone know off the top of their head? And why would they have huge amounts of data or huge amounts of,
Is it the National Research Organization?
Good guess, but no. Let's see. They are the National Reconnaissance Office. They in fact weren't actually, they actually were not officially acknowledged for like the longest time. Like they were a very secret kind of organization. And if you see their Wikipedia, designs, builds, launches, and operates the reconnaissance satellites of the United States. So they were established in 1961 and declassified in 1992. So it was a classified organization. Now, since they're taking about a bunch of satellite data and sifting through it, that makes sense why they would have tons of that. Pretty much. I mean, both are spy satellites and are not spy satellites. NGA is for military. They do military stuff. But like you can see, there's a lot of stuff. And this was done like years ago. So this may be out of date because Amazon, Facebook, and Microsoft have gotten huge. And so what he does, he breaks down, okay, the best way I can figure this out is by looking at, figuring out how many servers they have. And the best way to do that is figuring out their electrical consumption. We can't go over and sneak over and get their meter. Wait, we can't we? Somebody should try that. But they disclosed in 2010, about 11 years ago, they used an average of 258 megawatts of power. So, and that we know that it uses 215 watts per server. And so they say, okay, how many servers do we have and how much server, if we assume that each server has 2 terabytes, then they're using 10 exabytes of data. So then punch cards, basically, how many punch cards would that be? Well, there's Boston. There's the last ice sheet, and this is how tall the punch cards would get. Anthony, I will talk to you after class about the quiz, just so I don't want to interrupt right now. Okay. So, anyway, so the question we're trying to solve here is how will we figure out the number of trees in the state of Washington, not Washington, D.C., state of Washington, very different thing. Yeah, I'm not trying to be like snide with you, Anthony, or anything. I'm just trying, I just really don't want to interrupt with this, but I will cover it for you and give you the full information. Okay. So how many trees are there in the state of Washington? So like, how would you think this out? Well, a lot of Washington is forest. So like so one way to try to figure this out is figure out how much Washington is in forest. Okay. If Washington is this much forest, then how many trees are there in forest? All right. So what I'm going to do is I'm going to split you up into breakout rooms randomly. And I'd like you to go ahead and try and work on this for like 10 minutes and try to just brainstorm this. Sound good? Yeah, I want you to be prepared to share your answers because these are about estimations. I want to see what your thought process, I want to see what everybody's thought processes are on making estimations. Okay. So I'm going to go ahead and stop sharing and now share. Yeah, that's a good way to do it. I'd say there's no bad answers, but at least 3 is probably a bad answer. Right. Man, that's a lot of breakout rooms. All right, so I'm going to sign automatically. All right, have fun, everybody. Anthony, if you want to stay behind, I can give you the details for the quiz.
Oh, I had a question.
Yes.
So basically, I don't know what's happening with my computer. I opened my Google Chrome, and it says that there's no internet, but apparently I do have internet, but I don't know. I tried using Safari, but it's still not working. I don't know what to do.
That is okay. So furthermore, you're on a Mac and I don't use Macs. So other than in the fact that they are a Unix computer. So I don't know. Have you tried restarting?
I did.
Oof.
But apparently my Zoom works, but
okay, that is really weird. And web browser can't connect to internet. And then not really sure.
I tried using my phone, and my phone it works, but I don't know, my Mac doesn't work.
That is weird. I really don't know. I would go and ask the tech support people.
All right, yeah.
That is fixing. This is something that would take me quite a while to fix.
All right, yeah.
Because I'm not familiar with this issue.
Uh-huh.
Okay.
All right, thank you though. Can you add me to group room 23? I was in there.
Are you not able to rejoin?
No, because I denied, because I was gonna talk with you, but
23.
yeah.
Oh, I can just move you to a different room, which I just did. So.
Professor, I just lost connection and joined back in. Can you assign me to a breakout room?
Sure. Give me 1 second.
Thank you.
Okay, I'm gonna just yeet you into room 23. Okay. Anthony, you still there? Is anybody having trouble joining the breakout session? Okay, I think everybody should be back at this point. So people should be able to hear me. All right, so I'm going to enable screen sharing globally. Dangerous move, I know. In fact, I think it was already enabled, but would anybody like to share their group's answer and their group's reasoning? Remember, there are no bad answers unless that answer is at least 3, which is hilarious and technically correct, but not what we're really going for.
I can share mine.
Sure, go ahead.
Hold on, let me try this.
Mm-hmm.
Sorry. Oh yeah, I have to go my system preferences and allow this.
No worries. Does anybody else want to go in the meantime? Or have you got it?
I'll give it a shot.
Okay, great.
So did you want me to screen share or
Yes,
just?
go ahead and screen share if you feel comfortable doing that. Otherwise, you can explain your logic and reasoning.
Okay, what I did was, I Googled how many square kilometers Washington state is. I also Googled how many trees can fit in a square kilometer. And I looked at a satellite image of Washington to see approximately the percentage of area covered by trees. And I used those numbers in, my program.
So what did you calculate? So what did you, how many-
I had an input, how many square kilometers is Washington? Kilometer, is the integer, and the calculation was trees equals kilometers times approximately 75,000 times approximately 45%. And
that's
then
not bad
print,
guess.
yeah, and then print there are blah trees. And
That's pretty good reasoning. I also, yeah, somebody says they did the same thing, but in acres. Gabe, I do see your hand. Just 1 second. It was a very good idea to basically to ask the question. Normally, I personally was thinking asking the question, how many trees are there? Does there need to be for something to be forest? But you asked a great question, which is how many trees can fit in a kilometer? That's a great question. Gabe, go ahead.
What we did is we did a little more pared down. We just looked at the density of trees in the state of Washington, and then we just found out the amount of acres in Washington. And through Google, we found out that there was on average 25 trees per acre in Washington and 43 million acres in Washington. So our calculations were just Washington equals 43 million, trees equals 25, and then the print was just Washington times trees. And yeah, we found that there was 1,075,000,000 trees in Washington.
Not a bad guess. I don't know what the right answer is, by the way, so that's why I'm saying, but I mean, like, it's your reasoning is sound. And if you did acres versus square kilometers, both are completely valid units because they're measuring distance. And so long as you've got they're measuring area, and so long as you have the appropriate numbers, that's fine. But this is kind of the idea of how to break it down. Does anybody else want to share before we move on?
I can share ours.
Okay.
We found that there were about 22 million acres of forest in Washington, and then there was about like 400 to 500 trees per acre.
Mm-hmm.
So then in their forest, so then we just multiplied acres of trees by trees per acre, and we got about 9.3 million.
9.3 million. That's a very different answer than a billion. I think that is, I don't know. Let's see. So, I mean, let's turn to Google for a second. How many trees? Did you say billion or million?
Me?
No.
I'm sorry, did I say I meant billion?
Okay. You said
Not million.
I changed mine. I did it the same way she did. I changed it from how many areas forested and then multiply by how many trees will fit in a certain area. And it had the same. It had 9 point something billion.
Yeah, billion is definitely, if you're in the billions, you're definitely in the right ballpark. Again, nobody really knows the exact answer to the question, but billions is what makes sense here. There's a lot of trees, and good thing they don't just come to life and take revenge on us for turning them into a bunch of paper. So, All right. So, but no, those are good answers. And you can see that like you can take big problems and you can break them down into small pieces just by thinking about them. So like the biggest thing to get over is when you're asked a question, is there's this panic instinct, you know, because the question is too big or too hard. And it's just very important to learn about, to calm down and say, okay, can this be solved versus can't this be solved? And we actually have this, and part of computer science in the algorithms class and the automata class, even more specifically, is actually proving what you can and can't be computed. Remember, computer science is the study of algorithms. It asks what can be automated efficiently, which means what can we compute? And so thinking about problems that can't be computing is what we do. And it's okay to feel panicked at first and to feel overwhelmed. But but it's a big question. And the only way you can solve big problems is by breaking them down into little problems and making them much more manageable. So let's take a look at another example of this guy. How many handshakes? And this is our last one. Okay, and it's related to 6. Let's see. So how many handshakes? How many handshakes would it take for everyone in your class to shake hands with everybody else? I'd say it would take a while because, you know, we're all in a virtual classroom here. So, you know, and there was just a recent storm. So getting everybody in one place is going to be a bit tricky. Plus there's a pandemic, you know, but realistically, if we were all in the same place, how long would it take for everybody to shake? How many handshakes would it take for everybody to shake hands with everybody else? You should not shake hands with any person twice, and you don't shake your own hand. Oh, nice, Mark. Very nice. At least 3. That's going to be a thing this semester. So the secret to solving this problem is to start small. What if the class had only 2 people? Well, if they what if there was 3 people, 4, 5? Once you figure out the pattern, that's where we want to start. Well, let's think about this for a second. What if this class had only 2 people, right? We'd want to shake hands with
Wait, are we saying that there's 2 additional people? Or are you including that 2 people? So there's actually only,
what if the
2
class
people.
only had 2 people, you and somebody else?
Then it'd be 1 handshake.
Yep, as Ben put it, there'd be 2 homies exchanging 1 handshake. What about 3 people, right? I would shake, Alice would shake hands with Bob, Bob would shake hands with Carl, and then Alice and Carl would have to shake hands. Why Alice, Bob, and Carl? ABC. Alice and Bob are very common example names we use in computer science. Oh, right. I should share my screen at this point, but thank you for the reminder. It's not really, at this point, it wasn't really necessary because here's the prompt and you can see it on your computer, but thank you. I thought I was sharing my screen. Okay, got too caught up in the problem. All right, so, right, we'd have to do with 3 people. So so here I'm gonna start writing comments. So I have some notes, right? 2 people gave me 1 handshake. Okay. 1 gave me 2. If we have 3 people, right? Sorry, no, 1 person has 0 handshakes because they don't shake hands with themselves. A factorial approximation isn't the worst idea, but let's see. But we want to confirm we need to confirm the pattern.
Wouldn't it be 3?
And so, yeah, 3 people with 3. Now 4 people.
6.
4, well, let's see. Alice has to shake hands with 3 other people. Bob has already shaked hands with Alice, so she has to shake hands with 2 other people. So, and then Carl
It
needs
would
to
be 6 handshakes.
Yep. So 6. And then 5. So what is the pattern here for 5?
It would be 10 handshakes.
And how do we get that? We had 5 people. Alice has to shake hands with 4 people. Then the next person has to shake hands with 3 people. Why 3 and not 4? Because they've already shook hands. Yes, if you know how to use a for loop, you can use it.
So then the next guy is gonna have to shake hands with 2 people and then 1 person and 0 people.
Yeah.
So how is this not, how can we not use this factorial for this?
Well, we're adding.
Oh, not multiplying, you mean?
Yeah, we're adding, not multiplying. All right. In fact, I actually recognize this series. It's a series I am intimately familiar with. And if you've taken Calc 2, you may be familiar with it as well. So let's go ahead. There is a formula for this. But go ahead and see if you can't figure out that formula on your own and try to figure it out. So once you get the pattern, try to figure it out. So I'm going to break you up into breakout rooms. Oh, wait, no, it's 310 already. So we don't necessarily need loops. So I'll go ahead and just continue with the answer over here because it is 310, it is 312, and I don't want to necessarily do this. So what we see here is a sequence. So 6 is 5 plus 4 plus 3 plus 2 plus 1. And yes, we can use a loop to do this. And a loop, for those of you who do not understand, and you could make a function, but you don't need those if we can understand the math here. Okay. 6 is going to be 5 plus 4 plus 3 plus 2 plus 1. So 9.
15.
15. So now we're kind of getting somewhere. So now what about 7? I think that should be our last data point. 7 is going to be equal to 21. That's right. It is actually each time we're adding the previous number, aren't we? Right? One where it's like a smaller Fibonacci, right? The difference between 3 and 2 is 2. The difference between 4 and 3 is 3. The difference between 5 handshakes and 4 handshakes is 4. The difference between 6 handshakes and 5 handshakes is 5. The difference between 7 handshakes and 6 handshakes is 6. So what this is, if I'm looking at this correctly, is that this is what's called the triangular number series, which of course you would all know that what I'm referring to by the triangular number series, right? Obviously. But it's one that I'm familiar with. So, and I know this because I spent way too much time in mathematics, but they're called triangular numbers because they go like this. That looks like our sequence, right? Where you have one, where basically they're the number of dots we need to make a triangle. Right? So 1 dot to make one triangle 1 high, 3 dots to make a triangle 2 high, 6 dots to make a triangle like this. Does that make sense to everybody? Like why they're called the triangular number series?
Yeah.
Because they stack
Because
up.
they make a triangle.
Yep. They stack up and make a triangle, right? And so each time we add a line here, it ends up being 1 plus 2 plus, so the nth number is 1 plus 2 plus 3 plus 4 all the way up to n. That's how I know it. We know it from calculus. And some of you were going permutations, and you're right. There is a permutation, which is n plus 1 over 2. The formula for this, as you'll learn in data structures as you get this point, or in Calc 2, is n times n plus 1 over 2. And I think that's a bit weird to try to derive that in this short class period like this. But let's go ahead and see. People were suggesting loops. What was that? Well, loop is something that runs a certain number of times. So let's see, input. How many people? Question mark space. Num is equal to this. All right, so how many people? And a for loop, which we'll learn in week 4, looks something like this. For I in range 0 to,
Num,
yeah,
-1.
not num -1. We don't need to do -1. I'm just trying to figure out if I want to include num here. Because, yeah, because I don't want to include, one should be one. Because if we've got, okay,
Oh, so you're just gonna start at 1, yeah, because,
because,
isn't,
let's see,
it
so.
starts at 0, right? Versus like MATLAB, which starts at
Well,
1.
the issue is here that we've got basically is that the series is off by 1
Mhm.
from the original series. First, let me just start off by saying this. This will run anytime you see this. And this is a couple weeks ahead. This, whatever's inside this indent will run a certain number of times. And I realize if I put this here with 3 minutes left in the class, I'm going to lose most of the class. So let's not. But you could write a for loop. I'm just avoiding the for loop because there's only 3 minutes left and I don't have time to break it down. And again, it's a couple weeks ahead. But we could solve it with a for loop. But the total would be how many people? It would be n times n plus 1 over 2. So we'll try this. And we're going to see that we're not going to, I don't think we're going to get the correct answer. We're going to type in 21 and I think, sorry, we're going to type in 7 and we should get 15, I think. N is not defined, right?
Yeah, you should be.
Oh, right. What did I forget to do? I forgot to convert. So if I put in 7, I'm going to get 28, the nth number. So what I'm going to want to do over here is, right, because now the reason that we're getting 28 as opposed to 21, now 28 would be the next number in the sequence, right? Why is 28 the next number in the sequence? Because there's between 7 and 8, we have 7. But the issue with this formula is, notice the first triangular number starts at 1, then 3, then 6. So 1 gives us 1, 2 gives us 3, 3 gives us 6, 4 gives us 10. 1 gives us 0, 2 gives us 1, 3 gives us 6. Oh, sorry, 3 gives us 3, 4 gives us 6. So we are getting, something a bit off. So we can subtract 1 from each of these, which we can just simply rearrange like that as was suggested in chat. And we'll get 21. So what I did was I subtracted 1 from each of those. I know it looks like I subtracted 2 from one of them, but what I did is I subtract -1 over here. I'm subtracting 1 from n to make n 1 less, to make it match with our thing. Right? So I subtracted 1 from each of them. And now I can just also just rearrange this so that I have, make sense? So that's how I got to my previous, how I got to from n plus 1 to n minus 1. So if there are, now what's cool about this is that this does grow fairly quickly. There were 134 people in chat at one point, so I can put that in and we would see that there's 8,911 handshakes to make. See how many participants are there actively right now? There's 120 of us right now. 119, we're dropping like flies. So yes, Ishan. I saw you raise your hand for a second.
Sorry, Professor, that was my mistake.
Oh, no worries. I figured since it immediately went back down. Okay, I will go ahead and share this code with you. So you can go ahead and load it and run it yourself by refreshing. Be sure to enter the questionnaire down here so I can look at how horrified you were as a student. And so I can take that feedback into account. But otherwise, Class is over.